let's take a look at a type of function that perhaps we haven't seen before. Let's take a look at what's called exponential functions. Exponential functions. Now, now we've seen polynomial functions in the past, right? Such as f of x. So let me just say polynomial function. We've seen before. Let's recall. Right, polynomial functions. Alright, so things like f of x, for example, equal to 3x squared minus x plus 5, right? This is the quadratic function, for example. It's still a polynomial, basically, right? And we've seen linear functions, right? Linear also can be classified as polynomial function, but something like mx plus b, 4x plus 5, for example, right? So we've seen radical functions, right? Let's look at radical functions, such as square root functions. F of x equal to the square root of x minus 7, for example, right? So we've seen these types of functions already up to this point. Now let's take a look at what's called exponential functions. This is where the exponent becomes the variable. In other words, x is now going to be in the exponent, right? So let's take a look at the standard form for the exponential function here. Let's take a look at what's called an exponential function. Exponential function. Alright, so the format for that is going to be f of x equal to a to the x, where a is my base, if you recall exponential expressions, right? So my a is the base, and my x, my variable, is the exponent now. So x is now in the exponent. Okay, so the calculations are a little bit more involved. So because x is in the exponent, all right, but the concepts will be similar to the past, all right, in terms of working with exponents, which that we have done up to this point, all right. So let's take a look at now. First of all, before we move on with that, let me say something about the base. First of all, the base is going to be a positive number, and also the base is not equal to 1, because 1 to anything is just 1, right? So it's not equal to 1, and it's a positive number, let me say. So let's look at a real simple exponential function then, and do some calculations with it, and as well as graph it, right? Let's go ahead and do that. I'm going to clear out the screen. So let's take a look at something like this. Let's take a look at something like f of x equal to 2 to the x. Real simple exponential function. So my base is 2, and x is the exponent, right? Now let's go ahead and calculate some, do some calculation. Let's go ahead and find, for example, let's find f of 2. Let's find f of 0. Let's find f of negative 3. For example, let's calculate these three function values. So we're plugging in these three numbers for x into this function. All right, so let's do that. So let's start with f of 2. That's not too bad. That's simply going to be 2 squared, isn't it? All right, plug in 2 for x, which is going to be 4. Okay, so the function maps the 2 in the domain to 4 in the range, basically, right? What about f of 0, right? And f of 0 gives us the what? The y-intercept, because x is 0 right here, right? So what's the y-intercept? Well, it's 2 to the 0 power, which is what? 1. So the y-intercept is going to be 0, 1 for this particular exponential function. All right? What about f of negative 3? Well, let's go ahead and see if we can do that, right? Let's plug in negative 3 for x, 2 to the negative 3. What you call negative exponents, we simply bump it down to make it positive, so 2 cubed, basically, 1 over 2 cubed, which is 1 what? 1/8, 2 times 2 times 2. All right? So what I'm trying to show with these three function values is that in terms of domain, you can plug in, what, 0 for x, you can plug in a positive number for x, you can also plug in a negative number for x. So we can say that the domain for this particular exponential function is what? All real numbers. All real numbers. In fact, for the general form I had earlier, that is in fact the case. All real numbers. Or we could say negative infinity to infinity if we're using interval notation, right? Domain is all real numbers. Okay. Now, what about the range? Well, let's do a few more. Let's go ahead and find f of negative 5, and also do one more here. F of, let's say f of 7, for example. All right. So let's do f of negative 5. Just plug in negative 5 into this function for x. So this is 2 to the negative 5, all right, which is 1 over 2 to the 5th, which is 1 over what? 32. You punch out the calculator, 2 to the 5th is 32, all right? What about f of 7? F of 7 is going to be 2 to the 7th, which is going to be what? See, the calculator 128, I believe, on the calculator. You punch in the calculator. But here's my point. No matter what I plug in for x, right, be it a negative number or a positive number, look at the y value. It's always going to be what? A positive number. Yes, this is a very small fraction, 1 over 32, but it's still a positive number. All right. So my point is that for the range of this exponential function, the range is all positive numbers. All positive numbers. All right. Range is all positive numbers here. All right. So we can say that then the range in terms of set builder notation, or well, let's use interval notation. That'll be what? From 0, not equal to 0, so it's never going to be 0, regardless of what negative number you plug in for x. It's always going to be a positive number, so we're not including 0 here in the range. 0 to infinity. Okay? Or in set builder notation, it'll be what? All numbers, all real numbers y being the range, right? Y greater than 0. Okay? You can say it either way. But yeah, keep that in mind for the exponential function of that form. All right, so domain is all real numbers, and range is all positive numbers. Now, let's go ahead and graph this function 2 to the x. Let me go and clear up the screen here. And the way we graph this, the way we graph other functions in the past, right? We simply make a table of x and y, or x values and function values, my y being the f of x. This is my y, right? All right, so just pick x, plug it in to get the y, just as we've done in the past. Let's pick x to be 0. We did it earlier. 2 to the 0 is 1. Pick x to be 1. 2 to the first power is 2. Pick x to be 2. We did that earlier here. 2 to the second power was 4, remember, right? Let's pick x to be 3. 2, what's 2 cubed? 2 cubed is 8, all right? Again, it can also take on negative numbers, right? Remember, domain is all real numbers. Let's try some negative numbers. How about negative 1? 2 to negative 1. Well, 2 to negative 1 here on the side, maybe. That's 1/2 if I convert to positive exponent. So 1/2 for the function value. All right. Let's try negative 2. That's going to be what? 2 to negative 2. 1 over 2 squared. Right? Or what? 1/4. All right. So 1/4. All right. And negative 3. 1 over 2 cubed. We did that earlier. That was 1/8. All right. So my point is, yes, as I pick more negative values for x, the function values are going down, right? But they're heading towards what? Heading towards 0, but it always stays above 0. It always remains a positive number when you take 2 to a negative power even, right? But let's see what the sketch of the graph looks like. We just plot a few of these points here to give you an idea here, right? So now these numbers get big in a hurry, as you can see, right? Because if 3 is if you plug in 3 for x, you get 8. 4 is going to be what? 2 to the 4 is what? 16. 2 to the 5th, 32, right? It gets big in a hurry. Okay, so I'm not going to account for all those values, obviously, but you see, you get my point here, right? So, anyways, I just go up to 8 here on the function value. 1, 2, 3, 4, 5, 6, 7, 8. All right, and then we did a few negatives as well. 1 and 2. I'll just go there. 1, 2, and 3. All right, so 0, 1. So the y-intercept is going to be 0, 1. 1, 2. 1, 2. Notice also that since the function values remain positive, right? In other words, f of x is never going to be 0, right? It stays above 0, always greater than 0. Notice it never touches the x-axis. In other words, it has a y-intercept, as we have 0, 1, right? But it does not have what? An x-intercept. So there are no x-intercepts here. Keep that in mind. But anyways, let's plot these points and see what the rough sketch looks like here, right? So 1, 2, 2, 4, 2 and 4, 3, 4, 3 and 8. So 3, get my sketch pad working again. All right, so 3 and 8 all the way up here, roughly. And let's try some negative values for x. Negative 1, 1/2. So negative 1, 1/2 is roughly here. And 1/4, negative 2. But again, it heads towards 0, but it never stays above 0. So in other words, the graph's going to tail off on the x-axis. Right? So don't touch the x-axis. So here's the rough sketch of the curve here, to the best I can with the sketch pad. Apologize for that. and make sure your graph tails off along the x-axis. Right? So this is the function of 2 to the x in terms of the graph. All right? So graphing this is not bad. Make a table, but again, the values do get big in a hurry, so just look at the sketch of this. Right? Let's go and try another one. Let me go and clear out the screen. Take a look at f of x equal to 2 to the x. Let's make it 2 to the x minus 1, for example. All right? Let's try this one. Let's make a table here. Let's go and graph this. All right? But again, let's pick numbers for x here. So let's pick 0 for x again. Plug it in. So 0 minus 1 is negative 1. So that's going to be 2 to the negative 1, which is what? 1/2. Okay, so be careful on that. Pick x to be 1. 1 minus 1 is what? 0. 2 to the 0, 1. 2 for x. 2 minus 1 is 1, so 2 to the first power, or just 2. 3 for x. 2 to the third, minus 3 minus 1, excuse me. 3 minus 1 first. Apologize, but that's part of the exponent, right? That's the exponent. 3 minus 1 is going to be 2 squared, or 4. And then 4 first. Do one more. 4 for x, or 4 minus 1 is 3. So 2 cubed, we get 8. All right? Let's try some negative numbers. Negative 1 for x. Negative 1 minus 1, so that's 2 to the negative 2, or what? 1/4, right? You push the 2 down. What's 1 over 2 squared, right? Okay, so, but you get the idea here. This is negative 2 minus 1 is negative 3, so 2 to the negative 3. That's 1 over 2 cubed. I show some work here, which is 1/8. But again, the function remains above the x-axis, as you can see. The y values stay positive. All right. Now, if you notice, also compare this table with the last table we had. I just cleared out that screen. You see that the y-intercept, instead of 0, 1, now is 0, 1/2. All right. So let's take a look at the concepts a little bit here on that. So let's go and plot the graph real quickly here. So 1, 2, 3, 4, 5, 6, 7, 8. All right, 1, 2, 3, 1, 2, 3. All right, so there's x here. All right, so 0, 1/2. So 0, 1/2 is now my x-intercept. I mean, like the y-intercept, should say. Sorry, y-intercept. Apologize for that. 1, 1. All right, 2, 2. And 3, 4. 1, 2, 3, and 4 up here. And 4, 8, all the way up here. All right. And negative 1, 1/4. I'm sorry. Negative 1, 1/4. Okay, so basically it's going to tail off again at the x-axis. I couldn't quite plot 1/4 here with the sketch pad, so I apologize for that. But again, the graph's going to tail off. But my point I wanted to make, though, sorry about the confusion I'm causing any here. But the key is what? Just be able to make a table and be able to graph this, right? Not a big deal. The general shape looks like that. But the key, though, also is that, not the key, but I want you to compare the table here with the previous table. And that is, here I replace x with x minus 1. Right? If you remember from last time we talked about translation, right? Those concepts can still be used here, right? This graph is the same as the previous graph, except we're shifting it 1 to the what? To the right, moving everything 1 to the right. Okay, so this is let me say this is same as y equal to 2 to the x that we did right before this, right? But shifted, so you can use concepts of translation here, 1 to the right. If you remember, if you replace x with x minus 1, you're shifting the graph 1 to the right. So let's recall that. Again, if you didn't know that concept, that's fine. Just know how to make a table, nevertheless. All right. Let's talk about the vertical translation. Let's go and clear out the screen. Try this one. Let's go and graph, for example, g of x equal to, let's say, 2 to the x plus, let's make it plus 3, for example. All right. So this should be the same as the 2 to the x graph we saw from the beginning, excuse me, but shifted. We're translating this what? 3 units up. Okay, so this is a vertical translation. Let's see if that's in fact the case when I make my table. and you compare this table with the original table again as you're taking notes here with this lecture video. Anyways, 0 for x, right? So 2 to the 0 is 1, plug it, plus 3, excuse me, so you get 4, all right? We're working on that. Plug in, pick 1 for x, 2 to the first power is 2, 2 plus 3 is 5. 2 for x, number's getting big now. 2 squared is what? 4, 4 plus 3 is 7, all right? Do one more, 3 for x, 2 cubed is 8, right? 2 cubed is 8. I'll show some work here, 2 cubed plus 3, this is 8 plus 3, right? 2 cubed is 8 again, 11, right? You get 11 as the y value, function value. Let's try some negative numbers, negative 1. All right, negative 1 here for x, that's a negative 1 there, sorry about that. That's 2 to the negative 1 is what? 1/2, right? This is 1/2 plus 3, or 3.5, okay? Negative 2. Negative 2, that's going to be what? 1/4, isn't it? 2 to the negative 2, so that's 1/4. But we're adding 3 to it, so 3 1/4. All right? But again, as you get more negative, pick more negative numbers, you're still going to be bigger than 3. Because remember, we're shifting this thing 3 up. Originally, we're always bigger than 0, right? Now we're always going to be bigger than 3 because we're adding 3 to the function. So think of this as f of x, if f of x is equal to that 2 to the x here, right? Plus 3. So you're translating it 3 up, shifting it 3 up. Right? Think about vertical translation for this problem if you like. But again, at least know how to make the table here to get the general sketch of the graph. But it's going to be the same sketch, right? Except that it's going to be shifted 3 up from the original. So let me go up to 11 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All the way up here, 11 here, right? So 1, 2, 3, 4, 2, 3, 1, 2, and 3. All right, so 0, 4 is now the y-intercept. Okay, 1, 5, 1, 5, 2, 7, 2, and 7 here, and 3 and 11 all the way up here. But again, make sure we tail off negative 1, 3.5, so negative 1, 3.5. So here, but tail off along this 3 right here on the y-axis. So your graph should tail off, should not go below the 3, right? Because remember, all the y values stay above 3. Same graph here. Sorry, but I didn't draw it real well, but it should be a nice curve-shaped graph staying above 3. Okay, so this is what the graph should be. So again, sorry for the sketch pad not working it properly here, unfortunately, so bear with me on that. But the same graph as 2 to the x, again, but shifted 3 up, bottom line. Right? Let's do one that's a little different from this. Let's go and make the x negative up here. So let's go and try this one. I'm going to clear the screen. Let's graph f of x equal to 2 to the negative x this time. Right, negative x. So let's make a table for that. Let's see how this one turns out in terms of the graph. All right. So let's pick x again to be 0. Plug it in. So, but negative x, so that'll still be 0, right? So 2 to the 0 is still going to be what? 1. 1 for x. Right now it gets more tricky. 2 to the negative 1 now. You pick x to be positive 1. That's 2 to the negative 1. 1/2. 2 for x. So 2 to the negative 2 then, right? So that's going to be what? 1/4. Okay. I'm not going to pick 3 because I'll get what? 1/8 if I do that, right? Let's try negative 1 though, right? Because that makes that positive, right? Because that will be 2 to the minus negative 1, right? Which is going to be 2 to the first power, which is going to be 2 in this case. Negative 2 for x. That should be positive 2, right, if I do that. 2 squared, like I see the work up here. That's going to be what? 4. Negative 3 for x. So the numbers are sort of switched around a little bit, right, in terms of the sign, right? As you can see, in terms on the domain values. But that'll be what? 2 cubed if I do that, because negative is positive, so positive 3, right? And that'll be 8. Okay, so let's see what the sketch looks like now in this situation. So let's see here. I need to go out to up to 8 again. So there's my x. So 1, 2, 3, 4, 5, 6, 7, 8. All right. 1, 2, and 3. 1, 2, 3, 4. 1, 2, and 3. All right. So let's see what the sketch looks like. 0, 1. Okay. Still good. My y-intercept is 0, 1. 1, 1/2. So 1, 1/2. So now the graph tails off. 2, 1/4. Tails off along the above the, so stays above the x-axis again, right? These numbers remain positive, right? But look at the sketch of, here's negative 1, 2. Negative 1, 2 is here. negative 2, 4 is here, and negative 3, 8 is up here. So the sketch is sort of rotated about the x-axis, right? But don't worry about these concepts. These higher level concepts are talked about in the next math class. Should you take a class such as college algebra, for example, right? But look, it tails off again on the x-axis on the right side this time versus the left side that we had earlier. Right? So the graph is kind of switched a little bit, turned a little bit on the x-axis if the x is replaced with negative x. All right. So, but again, don't worry about those concepts so much as know how to make a table to get the function values, the x values, and the y. So we're picking x, plug it in to get the y, just like we've done in the past. No big deal. All right. Except the calculations might be a little more complicated here, obviously. Let's look at another type of function that we have in a special type of exponential function. Let's look at what's called the natural exponential function, because it has many applications in nature and science. Natural exponential function. All right, and here's what that looks like. That's f of x equal to e to the x. All right, this number e is the natural number. This is not a variable. Right? This is a natural. This is called the natural number. Sort of like the number pi. Pi is a number, right? 3.14159, so on goes on forever. E is like that. E is approximately, you punch in the calculator, 2.718. But again, it's an irrational number. That means it's a decimal that extends forever, and the digits don't repeat. All right. So, but know how to work this number. We'll see more applications on that down the road. All right. Anyways, know how to work the e button, e to the x button in your calculator. Most importantly. All right. So let's say I give you this function here. Let's say, well, in fact, let's give you a function of this: f of x equal to e to the x plus 3. All right. I want you to find, let's find f of 0, f of negative 5, and let's find f of, let's make it f of 6 here. All right. So let's plug these numbers in for x and see what the function value turns out to be, using this e to the x button on our calculator. All right. So let's do that. So let's find f of 0 here. This is e to the 0 plus 3, right? Which is just e cubed, right? So punch into the calculator using the e to the x button. So I'll push 3 and then e to the x on my calculator. So I get roughly, let's round off to 3 or 4 decimal places here. So I'm going to go 20 point, again my calculator, 20.0855. So I'm going out to 4 decimal places here, all right? F of, let's plug in negative 5 now. F of negative 5. This is e to the negative 5. It's a 5 there, sorry about that. Plus 3, should be a 5, equal to e to the negative 2. All right, you work that out. Again, just punch in the calculator, negative 2. So negative 2, and e to that power in the calculator is going to be roughly 0. Again, it stays above 0, above 0, so it's still a positive number. 0.135, I'll just say. I'll go 3 decimal places there, roughly. How about f of 6 here? That's going to be e to the 6 plus 3, which is e to the 9th. That's going to be a pretty big number here, right? Let's take a look at it. So 9, use the e to the x button, practice that. Roughly 8,103, 0.084, 0.084 on my calculator. So know how to use this feature on the calculator, depending on the calculator you have, to evaluate this natural exponential function here. Right? So no big deal, we're just plugging numbers in, so not too hard at all. But the takeaway here is going to be what? To graph these guys, you need to make a table here, right? All right, let's recap some concepts here on the exponential function. Let's recall some concepts. Okay, so for f of x equal to a to the x, key facts here. Let's take a look at that. So first of all, domain. Domain is what? All real numbers. All real numbers for domain. You can plug in any x you want. Positive numbers or negative numbers. Negative numbers doesn't matter. Range, though, however, are only the positive numbers. When you do that, again, we're saying that the base is what, greater than 0, and the base is not equal to 1. Again, we call that a definition of the exponential function. Range is all positive numbers. All positive numbers. All right. In other words, from 0 to infinity. All right. bigger than, that's infinity there, sorry about that, bigger than 0. And last but not least, one I had mentioned there is that if you look at these types of functions, such as 2 to the x, or we had earlier, it passes the vertical line test, as well as the horizontal line test. So this is a one-to-one function. So one-to-one function. Which means what? Which means it has an inverse function. So it has an inverse function, which will be the logarithmic function that we'll get to next, an inverse function. All right. So again, any one-to-one function will always have an inverse. All right. So these are three takeaways. These are three properties to keep in mind here in terms of the exponential function. All right. Let's finish out then by giving you some prompts for Blackboard. Just some quick calculations on Blackboard using your calculator, so it's not a big deal here. So let's look at these prompts. I'm going to clear out the screen. All right. So I want you to let me just give you this function here, if you will. So let's look at f of x. Suppose f of x is equal to the natural exponential function e to the try again. Let me go and clear it out one more time. I want f of x, to be, let me get it right here this time, 3e to the negative 4x plus 1 plus 7, right? So the plus 7 is not part of the exponential, but the plus 1 is, right? Part of the exponent there, right? Given this natural exponential function, I want you to find the following values of f of x and post the answers into Blackboard, all right? So let's find f of negative 1. All right. Number 2, find f of 0. That's 0 there. And number 3, find f of 2. All right. So plug these three numbers in for x on your calculator so you can work it out. Round to 3 or 4 decimal places is fine. All right, and post it into Blackboard. All right. So until next time.